Hi, this is Hamza. I'm going to be going over how to multi-thread your OpenGL game engine. So let me just show you how it works here. I'm running in release mode right now. It loads in pretty quick. Everything's multi-threaded. All the textures get loaded, models in a background thread. So how I'm doing that is if I go to model builder here, it's basically just doing the regular model building but spawning a new thread. So one thread for all the models, one by one they get loaded. Once it gets loaded into memory, it gets dispatched into a thread dispatcher. What I'm doing here is sending a function to it, and the function will update every frame at the beginning of each frame on the main thread. So this is just a lambda function. What it's doing is it's setting the model information into the VAO on the main thread. So when I load the models, they don't clash with OpenGL at all. They'll just spawn in at the beginning of a frame once they're loaded. Same thing with textures. So what I'm doing here is spawning a new thread for these textures, and once it's loaded into memory, it's going to dispatch and load it into OpenGL, and the same thing happens here. It just loads all the textures. You see them popping in once they get loaded. And the other last thing I'm doing is, if you look here in the sky, the clouds here, they're kind of low resolution. These are actually being rendered from a 3D texture. I'll explain about it some other time, but the idea is I'm loading, if you notice in the background here, it was doing a lot of processing, and now it's not, because it's loaded a higher resolution texture and replaced it with the old one, or with the new one. And you can see this one has a lot more detail to it. There's a lot more going on with this texture. It's much higher resolution. So how I'm doing that is, I go to the rendering engine here. So I'm loading a 16-bit texture, or a 16 pixel texture, and then just putting that into the OpenGL texture loader, and then I'm actually spawning a new thread and calculating a 64 pixel texture in the background while the game is running. And then once that texture finishes, it's actually using promises. So what's happening here is this is also a lambda function that will update once the promise is, it returns a value, which is the whirly texture you can see here. And then it'll push that into the VAO at the beginning of the frame. So if I, for example, make this not threaded, if I change these defines here, it's going to single thread the model and texture. It won't have a huge impact just because of the size of the models and textures, but there is a slight delay. You can see it takes a little bit longer. But the real issue is when I go to the rendering engine here, and then I'm loading this 64-bit texture. It's going to take way longer. I don't think I'm going to show it because it takes like 30 seconds or something. So you can see, even with the thing not running in the background thread, I've also multi-threaded the actual texture generation. So it's still using up a lot of CPU, but it takes forever to get into the actual scene here. But the end product is the same, you can see. So I'm going to go back to threaded. And so this should work fine now. Yep, so it works fine. How I'm actually doing the thread updates is here. So I've got this thread class. It's a static class basically. You're pushing jobs. You can see a job, it has a is done, and then the dispatch function that it gets, and once it's done it'll just run the dispatched function each frame at the beginning. And then you can also just give it a function that you want to run on the main thread, and it will dispatch it once the update happens. So you can see here I'm using locks, so when you're pushing a job or dispatching a function, it actually puts that into a vector, and you need to lock the vector basically because it's not thread safe, the standard template library. So I'm locking using a mutex. This is a mutex here, right here, and it's actually locking this every frame as well as whenever you push a job so that there's no overlap. Just to be safe, I also, in the I think texture here, so basic texture manager, when you're getting the texture ID or setting it, it actually has its own mutex as well. Just to be safe, I want to lock things. In the case of, for example, in the model builder, it might load a texture from the FBX files, so you want to make sure that it's not clashing with this here. Same goes for the threading manager here. So that's how I'm doing it. I'm just updating every frame here. You can see it being updated in this game loop at the beginning of the frame. So thread update, and it'll just load all those models and textures into the graphics card, and then the result is pretty good. Thanks.